All right, welcome to the deep dive. Today, we're going to be looking at something that's seriously helpful, how to get specific information from websites and other more structured documents using this tool called XPath. And of course, all of this is going to be within the Python world. Now, you actually pointed us to a great resource for this, the Python XPath Selectors Guide, Master Web Scraping and XML Parsing over at Rebrowser.
Yeah, it's a good one.
So our goal today is to really break down XPath. I want people to walk away and know exactly what it is, why it can be such a game changer, and how to use it to laser focus in on the exact data that you want to get.
Yeah, and the guide goes into all of that. Like you said, it gets into XPath, it gets into the syntax, how it works with Python's LXML library, also gets into the applications, especially web scraping, kind of touches on best practices, performance considerations, challenges you might run into. So it really does cover a lot.
Yeah, it really does. So whether you're working on a project where you have tons of data that you've got to pull from websites, you're working with structured data formats like XML, or you just want to understand this fundamental tool, this is for you. We're going to be focusing on those core concepts and those practical applications and giving you a shortcut to being well-informed on this topic. We don't want to get bogged down in tech talk, and we want this to be as clear as possible. So let's unpack this. I think the first question is, for someone who's never seen XPath before, what is it?
So in simple terms, XPath stands for XML Path Language. It's basically a way to ask really precise questions about the content and structure of XML documents. So think of it like a highly detailed set of directions that allows you to pinpoint specific things inside these documents. It could be elements, it could be attributes, those kind of things.
Okay, so it was originally designed for XML, but as we saw in the guide, it's also really, really good at handling HTML, which of course is the backbone of most websites out there. So how does it make that jump? How does it go from XML to HTML?
Yeah, that's an important point. So while XML was its first language, XPath's ability to view structured documents as a tree makes it incredibly versatile, right?
Yeah.
So you can also apply it to HTML. And when you do that, it basically looks at the code, the HTML code, as a hierarchy, a tree of those elements, and then the properties that those elements have. And this lets you, use the same XPath language to find and select the specific information that you want from that web page.
Okay, so let me see if I understand this. If I'm on a website, XPath is almost like having this incredibly accurate address system to find, a specific sentence, a specific link, a specific piece of data that's buried somewhere in that kind.
Precisely. You got it. You can think of it like a library, like a giant library with all these shelves, all these books. And in those books, you need a specific sentence. So think of XPath like that librarian. It knows exactly where to go, which shelf, which book, which sentence to pull out.
Okay, this is starting to make sense now. Now, XPath sounds really powerful, sounds really useful, but the guide also mentions CSS selectors. I know I've bumped into CSS selectors. I've used them in some web design stuff that I've done in the past. So why would I go with XPath instead of CSS selectors when I'm trying to do data extraction? What is the advantage that it gives me?
Yeah, that's a good question. And it really gets to why XPath is so useful for data extraction. Like you saw in the guide, in those survey results, a lot of people that work with this stuff use XPath every day. And while CSS selectors are great for styling, you're right, and they can also pick out elements. But XPath gives you a lot more power and flexibility. And this is especially true if your goal is to extract data from these sources.
Okay, I'm intrigued now. What can XPath do that CSS selectors either can't do or would take a lot more work?
Okay, so for starters, XPath can go up the document tree, right? It can go down, but it can also go up. So let's say you've got a specific piece of content selected, you can actually go back to its parent or even further up that structure. Now, CSS selectors, they typically can only move downwards, so it doesn't give you that ability to reverse, to go back up the tree.
That's really interesting. I can see how that would be helpful, especially if the element that I'm looking for, the exact element I need, doesn't have a unique identifier on it, but its parent element does. So you can use XPath to sort of climb up the tree to get to the information that you need, which is something that CSS selectors can't really do directly.
That's a good example. That's exactly what it is. And then on top of that, XPath also has these built-in functions that make it even more powerful. For example, you can select elements just based on the text that they contain. It has functions like contains or starts with, like you could say, give me all the elements that contain the word sale, and it would find them for you. It also handles more complex conditions, more complex patterns for finding these nodes. And in some cases, if you have really intricate queries, XPath can actually perform faster than CSS selectors.
Wow, I did not know that. So we're talking about more versatile attribute selection. It can do math. Sounds like it's way more than just making things look pretty on a web page.
Exactly. So you can actually perform calculations. You can do math on attribute values. You can use functions to manipulate them. So it's a lot more analytical capability that you don't get typically with CSS selectors. So if you really need to pinpoint and get detailed data extraction, XPath is often the better solution. It's more robust, it's more capable.
Okay, I'm starting to see why this is such a popular tool. Now, the guide talks about XML and HTML having this tree-like structure, right? Can we dive into that a little bit? Maybe use that simple HTML example that they provide in the guide to illustrate how this works.
Sure. So if we go back to that example, which is, .html.html.head.title,
Sure.
sample, page.title.head.body.div, class, container dot main title one, p content paragraph, edify div.body.html. So you basically have the HTML tag, think of that like the root of the tree, and then right below that you've got two main branches. You've got the head and then you've got the body. Head has things like the title. Body will often have things like a div element. And this div, that's yet another branch, and that contains an H1 and a P element. So you can see how it's kind of branching out like a tree.
Got it. And so each of these things, HTML, head, title, body, div, H1 of P, these are all considered nodes on the tree. Is that right?
Yeah, that's exactly it. So in XPath language, we call these element nodes. Now, there are other types of nodes, too. There are attribute nodes. So like in that example, you see class container inside the div tag. Think of that like extra information, like an extra label on that element. And then you also have text nodes. And that's the actual content. So sample page inside the title tag or main title inside the H1 tag. So XPath lets you navigate and select any of these nodes within the tree structure.
Okay, I'm starting to visualize this now. So how do we actually use XPath? Let's bring this into Python. The guide talks about getting your Python environment set up, getting everything ready to go.
Right. So before you can use XPath in Python, the guide emphasizes the importance of setting up your environment the right way. It recommends using a virtual environment. That's always a good practice when you're working on Python projects because it keeps your project dependencies, your tools, separate and organized. So think of virtual environments like isolated boxes for your projects so different tools don't clash, different versions don't clash. It's really important to keep your data extraction projects running smoothly.
Yeah, I've used virtual environments for that very reason. It just makes managing different versions of different libraries a lot easier, and it just keeps things clean, keeps things organized.
Absolutely. It prevents those conflicts between different projects. You might need one version of a library in one project and a different version in another. So it just gives you a nice clean space for all the tools you need. So the guide also talks about the essential Python libraries that you need for working with XPath. And the core library is LXML. It's like the champion for XPath in Python. It's incredibly fast, fully supports the XPath standard. And if you're planning to fetch web pages, which is usually part of web scraping, you'll also want requests, that library.
And the guide also mentions Parcel and Beautiful Soup, but as optional extras. Is that right?
That's right. So Parcel can give you like a more consistent way to interact with data after you've extracted it. It can be really helpful for large, complex scraping projects because it works well with other tools that you might be using for scraping. And then Beautiful Soup 4 is a really popular HTML and XML parsing library. It doesn't have built-in XPath support, but you can actually use it alongside LXML. So you'll still need LXML, but Beautiful Soup 4 can do other helpful things for certain tasks.
Yeah, I've used Beautiful Soup 4 in the past, and it is really, really helpful. So it sounds like LXML is like the main engine here. What are the specific commands to install these libraries?
Yeah, so the guide gives you those commands. You basically use pip install, LXML request, Parcel, Beautiful Soup 4. That's it. Assuming you have pip, which is the package installer for Python, it usually comes with Python, so that should be all you need.
Perfect. And then how can I double check that I have everything installed properly?
Yeah, so what you can do is just run those import statements. You can import LXML, import request, import parcel, and then you can print out the version numbers. So you could do something like print LXML version.lxml version, and so on. And that's a good way to make sure that those libraries are installed and they're accessible and your Python environment can find them.
Perfect. So we've got our toolbox all set up. Everything's installed. Let's get to the real heart of this now. XPath syntax. Now, when I look at this, it looks a little different from the standard programming languages that I'm used to working with. Can you walk me through some of those fundamental expressions?
Yeah, sure. So XPath syntax, it uses what we call path expressions, and these are kind of similar to navigating like your computer files or folders. So let's start with maybe the most versatile one, the /A. This lets you select any nodes within the document, so it doesn't matter how deeply they're nested. So if you do div, it'll grab every single div in that entire HTML document.
Okay, so that's a very, very broad way of searching, but it's helpful if you need to grab everything. Now, what if I
Yeah.
want to start at the top of the document and go from there?
Yeah, so if you want to be specific and start from the top, you'll use a single /a shay. So this selects from the root node. So if you do HTML body, that would specifically select the body element that's directly under the main HTML root.
Okay. And then how about what if I want to refer to the current element or maybe the container that I'm in right now?
So for that, you can use a dot dot. It selects the current node. You often use it with other expressions. So like DP will find all the P elements that are within the current element that you're looking at. And then you have a double dot dot, which selects the parent. So this is how you go up the tree. So if you have a specific paragraph selected, dot would take you to the element that contains that paragraph.
Okay, makes sense. And I noticed the at symbol. That seems to be when we're working with attributes. So.
Exactly. So at means you're dealing with an attribute of an element. So at class would select all the class attributes in the entire document. Doesn't matter what element they belong to. But if you want to get specific, like if you want to get the class attribute for all divs, you could do div at class.
Okay. That makes perfect sense. So that's a good overview of some of those basic expressions. Now, the guide also mentions these things called XPath axes. What exactly are those?
Yeah, so XPath axes, they define the relationships between a specific node that you've selected and the other nodes in that tree. So it gives you even more ways to navigate the document, right, based on the connections between these elements.
Give me an example.
Okay, so for example, ancestor will select all the parent elements of the current node. And it goes all the way back up to the root. So if you want to find, the main section above a particular paragraph, ancestor is really helpful. And then you have descendant, which selects all the elements that are nested within the current node, and it doesn't matter how deep they are.
Okay, so ancestor is going up the tree, and then descendant is going down the tree. What are some of the other key relationships, axes, that we can use?
So you have following. And that selects all the nodes that come after the current node in the document order. So think of it like all the nodes after the closing tag. And then preceding is the opposite. It selects all the nodes before the opening tag of the current node. Then you have self, dot, which is a simple one. It just selects the current node, but you don't use it that often. And finally, parent pert will select the direct parent of the current node. So it's kind of like using dot, but can be more explicit sometimes. So, understanding these axes gives you even more control, really fine-grained control over navigating and selecting things in your document.
Okay, that makes a lot of sense. So we're painting a really clear picture here of how this navigation happens. Now let's talk about putting this into action using Python's LXML library. The guide introduced this XPath parser class. Can you break that down for me? How's it structured? What does it do?
Absolutely.
Yeah.
So this XPath parser class is a great way to organize the common steps involved when you're using XPath, right? Whether that's web scraping or parsing XML, that sort of thing. The first method, the end method, that's like your setup, right? It takes the URL that you're working with and it kind of initializes the object.
So the fetch and parse method, it sounds like that's what actually goes out and grabs the content from the website and makes it usable with XPath.
Exactly. So fetch and parse is the one that actually does the work of making the request to that website, to that URL that you gave it. And it uses the requests library for that. It has basic error handling in there. It uses a try.except block to catch things like maybe the website is down, the URL is wrong, things like that. If it gets the page successfully, then it uses LXML to parse it into a tree. And that tree structure is what XPath then works with.
All right, so now we've got the website content in a way that XPath can understand. It's in that tree format. How do we actually run XPath expressions against that tree to find the specific information we're looking for?
Yeah, so that's where the getElements method comes in. So you give it an XPath expression, it uses that to actually run against the tree that we just parsed. It has error handling here as well. It's looking for etree.xpathAbleError. So that would be, if you give it like a bad XPath expression, that doesn't make sense. But if it's all good, then it will return a list of all the HTML elements that match that query. So it basically finds them based on that XPath address that you gave it.
Okay, and then getText and getAttributes, those look like really handy shortcuts to just pull out the actual information we want once we've located the right elements.
Yeah, that's right. So getText, it takes an XPath expression, it finds the elements using getElements, and then it pulls out just the text from those elements. So it gets rid of any extra spaces. GetAttributes takes the XPath expression, it takes the name of an attribute you're interested in, so like maybe href or class or something like that, and then it gets those attributes for all the matching elements.
Okay, that makes sense. So that example they gave, the A at href example, that's basically grabbing all the links, right? That's how we'd use it to grab all the links on a web page. And then the h1, h2, that vertical bar is basically acting as an OR, right?
Exactly, yeah. So that pipe symbol A
Yeah.
that lets you combine different XPath expressions. So you could get all the H1s and all the H2s.
Exactly. And with the A at href, you're right. So it's targeting all the anchor elements, all the A tags, and then it's specifically getting the value of the href attribute, and that's where the links are stored, right? And then the last example, that div at class content, this is showing you how to get really specific. So you're getting all the divs that have the class name content.
So this XPath parser class, it looks like a really practical way to organize your code. It makes a lot of sense. Now, the guide goes on to discuss some of the more advanced XPath techniques, really focusing on functions. What are some of the built-in functions that XPath provides? So XPath has a bunch of built-in functions that make it even more powerful, right? They let you manipulate data in really specific ways. And the guide kind of breaks these down into string functions, numeric functions, Boolean functions.
Let's go through each of those. Let's start with the string function. So one example they gave was contains text, specific text. What would that look like in practice?
Yeah, so you would use that to find elements that have specific text in them. So you can say div contains text, important, and that would find any div that has the word important in its text. It's like doing a keyword search right within the HTML structure.
That's really useful. And what about finding elements where a specific attribute starts with a certain set of characters, like, maybe all classes that start with prefix?
So for that, you'd use starts with. It's really simple. You would say div starts with at class, prefix, and that would find all the divs where the class attribute starts with prefix.
That's super useful. And then what about normalized space text? What's the benefit of using that?
Okay, so that's really useful when you have inconsistent spacing in HTML, which happens a lot, right? So normalized space gets rid of extra spaces at the beginning and end of a text. And it also collapses any multiple spaces down to just one space. So if you say div normalized space text, it's going to find all the divs where the text content after it's been cleaned up is exactly clean text. So it's a really great way to avoid any problems with formatting and stuff like that.
That is incredibly helpful. So that's the string functions. What about the numeric functions? What can we do with those?
So the numeric functions, those let you do comparisons, math, with numbers that might be within the HTML or XML.
Yeah.
So like you could say, give me all the divs where the data value attribute is greater than 100. You would do div number, data value 100. So the number function is trying to convert that text to an actual number so you can do math on it.
Okay. And then we have position, mod 2 = 1. That looks like we're selecting things based on their position or order in a list.
You got it. So position, that tells you the position of the current node in the list. And mod is basically a calculation that tells you the remainder after division. So what this XPath is doing is it's saying, give me all the list items, all the lie tags that are at odd positions in the list. So the first one, the third one, the fifth one, and so on. Now, it's important to remember that XPath starts counting from 1, not 0, like Python does. So the first element in the list is position 1, the second is position 2, and so on.
Okay, that's something to keep in mind. I can definitely see myself getting tripped up on that. So we've got string functions, numeric functions. What about Boolean functions?
All right, so Boolean functions, those are basically true or false functions. So they're used to filter the elements based on a condition. Like you could say, find all the checkboxes that are currently checked. You could say input at type checkbox and at checked. So it's finding all the inputs, all the input tags where the type is checkbox, and they also have the checked attribute. And there means that both of those conditions have to be true.
All right. And then that last example they gave for Boolean functions, the number text one, that looks a little confusing. What's the logic there?
Yeah, so that's actually a neat trick. It checks to see if the text in an element can actually be converted to a number. So if you have something like hello, that can't be converted to a number, right? But if you have something like 123, it can be converted to a number. So this XPath is basically saying, give me all the span tags where the text is a valid number.
So it's like a built-in data type validation. That's pretty cool.
Yeah, exactly. It lets you make sure you're only getting numbers, not strings or anything else.
Now, the guide also mentions briefly that you can actually use your own custom Python functions within XPath. So you can actually write your own logic and use that in XPath, right?
Yeah, you can. It's a little more advanced, but it's really powerful. So you can register your custom functions and then use them right in your XPath expressions. So the guide gave this example of a function called isValidate. And this lets you do more complex validation or calculations that you can't do with the built-in functions.
That's awesome. So this really shows how flexible XPath is. It's not just limited to these basic functions. You can really expand it and make it work with your own custom logic. Okay, so the guide talks about error handling and best practices. Why is it so important, especially when we're talking about web scraping?
Yeah, so error handling is like super important, especially for web scraping, because websites are constantly changing, right? And if even a small thing changes in the structure of the HTML, your XPath might break. So without proper error handling, your script might crash.
Hmm.
Or even worse, it might just silently start returning bad data and you won't even know.
That's a nightmare scenario. So the guide talks about this XPath handler class with the safe XPath method. What's the main benefit of using something like that?
Yeah, so the safe XPath method, it's basically a way to run your XPath expressions safely. It's got all this error handling built in so it can catch common XPath errors like bad syntax.
Yeah.
It uses try.except blocks, which are like safety nets in Python.
Yeah.
So if an error happens, instead of crashing, it can log the error, maybe return a default value or something like that. So it makes your code a lot more resilient.
Makes sense.
And how's the parse it safely method different?
So Parsed faithfully focuses on the very first step, which is taking that raw HTML content and turning it into an actual usable tree that LXML can work with. It uses a special option, recover, true, when it's parsing the HTML. And this basically tells the parser, hey, if you see any errors in the HTML, like a missing closing tag or something, try to fix it. Now, even with this, sometimes the HTML is just so messed up that it can't be parsed. And if that happens, the method will catch that error and return none, which basically means, hey, something went wrong. I couldn't parse this. And again, it prevents your script from just crashing, right? It gives you a clear signal that something's wrong.
Okay, so that's super important to include in your scraping projects. Now, the guide also gives a real-world example of using XPath to scrape product data from an e-commerce website. So let's break down that e-commerce scraper class that they provide.
Yeah, so this is a great example that shows you how to use XPath in practice, right?
Yeah.
And it's focused on getting structured information, specifically product details, from like an online store. So the first method in it takes the base URL of the website. So like, Amazon.com or something like that. And it creates a session, which can help your scraper be more efficient.
And then the get page method, this is what actually goes out and grabs the HTML content for each product page. Is that right?
Yeah, so get page takes a URL, it makes a request, a get request to that URL, and it includes something called the user agent header. And the user agent basically tells the website who you are, or at least it pretends to. So it can help your scraper not get blocked. And then it takes that content and it parses it using LXML again, so it turns it into that tree format.
Okay, and then the scrape products method, this is where the magic happens. This is where we actually use XPath to extract the data. And I noticed there's a dictionary in there called product txpath. What's the purpose of that?
Right, so scrape products is where all the extraction happens. And this dictionary product txpath, it's basically a really nice way to store all the XPath expressions for each product attribute. So it might have things like name, price, rating, reviews, availability, those kinds of things. And each key in that dictionary corresponds to an XPath expression that tells you how to find that information on the page.
So that makes it a lot more organized. You've got everything all in one place. You can see it. It's easy to update, easy to maintain.
Yeah.
Okay, and then it uses this XPath, tree.xpath, div at class product container, to select all the product containers on the page.
Yeah, so it's assuming that each product is wrapped in a div with the class product container. And then it loops through each of those product containers, and for each one, it tries to extract the data using those XPaths that we defined in that dictionary. But it runs them relative to the current product container, which means it's only looking within that product section of the HTML.
And then I noticed in that loop, there's some error handling in there. Specifically, it's catching index error and value error. Why are those important errors to handle?
Yeah, so index error can happen when your XPath doesn't find anything.
Right.
So let's say you're looking for the rating and some products don't have ratings, your XPath might return nothing. So then if you try to access the first item in an empty list, you'll get an index error. And value error can happen when you're trying to convert the text to a number. So let's say the price is formatted weird, it might cause a value error when you try to convert it. So, handling those errors makes your scraper a lot more robust, a lot less likely to crash.
Okay. And then finally, it creates a product data structure, probably a data class to hold all that information, adds it to a list, and then it's got a save-toxy method to save all that data to a CSV file, which is pretty handy. So that's a really nice, complete example. Now, the guide also talks about performance optimization, how to make your XPaths faster and more efficient. What are some of the key takeaways from that section?
Yeah, so performance is really important, especially if you're dealing with a lot of pages, a lot of data. So the guide recommends being as specific as you can with your XPath expressions. Avoid using really broad selectors like just div. Try to be more specific, include class names, IDs, or other specific attributes. Combining conditions into one XPath is also usually better than having several separate XPath expressions.
Okay, and then there was a brief mention of caching compiled XPaths. That sounds a little advanced. What's the benefit of doing that?
Yeah, so if you're using the same XPath expressions over and over again, you can actually compile them in LXML. And this basically saves some time because it doesn't have to reparse the expression every time. It's a small optimization, but it can add up, especially if you're doing a lot of scraping.
And then there was a caution against overusing the text function. Why is that?
Yeah, so the text function, it grabs all the text within an element, and that might be more than you need. If you just need like a small piece of text, it's often better to be more targeted in your XPath and just select that specific part.
Okay, and then some of the other tips that they mentioned, like connection pooling, using timeouts, retries, asynchronous requests, those make a lot of sense in the context of scraping, large amounts of data. Now, what are some of the common mistakes that people run into when they're starting out with XPath?
Oh yeah, there are a few classic ones. So one common mistake is not handling namespaces correctly in XML. Another one is assuming that all content is static. So with modern websites, a lot of content is loaded after the initial page loads. That's what we call dynamic content. And XPath on its own can't see that.
Right, so that dynamic content is something to be aware of. That's kind of a separate issue, but it's something that people need to understand. And then the guide also mentioned the problem of writing XPath expressions that are just way too complex.
Yeah, XPath can be really powerful and you can write these really complex expressions. But if they get too long, too complicated, it becomes hard to read, hard to understand, hard to maintain. So it's usually a better strategy to keep your XPaths as simple as possible, break them down into smaller chunks if you have to.
And then what about, not all pages are the same. Not all pages are going to have the same elements, the same attributes. So how do we deal with that?
Yeah, you have to anticipate that the data might not always be there. So if your XPath doesn't find something, you need to handle that gracefully. Otherwise, your script could crash.
Right.
Right. And similar to that is not paying attention to character encoding, especially if you're dealing with websites in different languages. If you don't handle that properly, you can end up with garbled text.
Yeah, that makes a lot of sense. And the guide also mentions the importance of being a good citizen on the web. So respecting robots.txt and using rate limiting.
Absolutely. So, robots.txt is basically a file that websites use to tell scrapers what they can and can't do. So you should always respect that. And rate limiting is basically slowing down your scraper so you're not hitting the website too hard. You don't want to overload their server.
Yeah, that makes sense. And then finally, if you don't have good error handling, good logging, it's going to be a nightmare if something goes wrong.
Yeah, you're right. It's like flying blind. So
Yeah.
always include good error handling and logging.
All right, now the final section of the guide talks about community insights and best practices. What are some of the things that stood out to you in that section?
Yeah, so one thing that stood out was the strong recommendation to use LXML. A lot of people in the community, they swear by LXML. It's like the gold standard for XPath and Python. And then there's a really good discussion about the difference between how the browser sees the web page and how your scraper sees the web page. So browsers can sometimes modify the HTML. They can add extra elements like T-body tags to tables. So just be aware that what you see in your browser's developer tools might be slightly different from what your scraper sees.
Right. And then that whole discussion about XPath indexing versus Python indexing, that's another one that can really trip people up. Expert.